My name is Danae Busby. I'm the Simulation Product Manager here at GoEngineer. And I just want to say welcome again, and I hope for the next hour or so you're able to understand our perspective of bringing these types of solutions to the product development community. And if you have any further questions, I'll be giving my name and information at the end of the webinar so that you can contact me for more information and or questions. So, as we get started here, the daily task of an engineer, as me myself being a design engineer, understanding that this is a phase of work that happens pretty much every day. Somebody comes to you with a concept, and that concept is either a regeneration of an existing product line or a next generation or an innovative way to rethink an existing product line or coming up with a new thought, plan, or idea, advancing or improving technology that's already in the market. Then you're responsible to design, which means define, create, develop that concept. And then after you complete the design, you of course want to prototype. You want to prove. You want to learn from the prototype. Understand where the failures might be. Understand where you might be able to redesign. And then, of course, you go into the redesign phase. You refine that. You re-engineer. You document that process. But typically, as a design engineer, and I know that all of you out there can understand this perspective, the iteration that happens between design, prototype, and redesign can be where you experience some of your most costly time spent in the product development cycle. So you prototype, and that can be costly because you outsource it, or you don't have the means to do that in-house, or you don't have the means to understand refinement in-house. So you may have to outsource to start the testing, or getting some consultants to help you understand where the failure points might be. Then waiting for that cycle to happen and bring it back in-house, and then refining that design based on whatever result you find, and then eventually coming to the manufacturing stage, where you begin to produce or retire or support that phase going out of the system. Well, the economy today and industry trends are really what's driving current products and pushing the line of innovation. And all that pressure really comes down to the engineers at the end of the day. And it's your job to understand, okay, how do I get to the end of the line quicker? Well, no longer can we do this gut feel sort of conceptual modeling with all of these pressures really pressing down on us, you know, increasing oil prices, Obamacare really affecting the medical device industry, defense cutbacks. Material costs have been a huge concern for quite some time in the product development community because raw materials here in the U.S., their prices are rising daily. Manufacturing costs, whether I do it here in the U.S. or overseas, that's a huge concern. And then you have these other components like environmental conditions. Green design is becoming a real element of how you produce products. So never before has it been really critical to hit the conceptual modeling phase really at a target or a bullseye. So gut feel is no longer the way we can approach design. If we're really going to get time to market and increase that time to market and reduce that product development cycle, we've really got to take the initial stage and cut out that over-designing component. You know, we've got to hit that target right away, do an improved design with real intuition from the start, right? And really getting to the part where we better design with strength up first reduced materials, and so we can prove to our boss, okay, this is the best design from concept. And we redesign the best design from concept, and sort of, instead of taking that gut feel approach where we're just milling for ideas and exploring our creative aspects of us being engineers, and coming up with the most favorable design, in a very targeted fashion. So you might be asking me, Danae, why would you be insisting that we drive design from a really refined sort of concept to begin with? Well, as design engineers, we want to evaluate those what-if concepts, even if that's, a thought that's in the back of our mind. And our bosses and those pressures are really causing us to say, okay, I've got to reduce these iterations. And so these pressures really demand that we quickly pass the conceptual modeling phase, go right into design, prototype, and redefinement. Becomes this sort of mold of all these cycles put together so that we can reduce that schedule, that production schedule, and get to manufacturing and really get product out the door. But still keeping in mind that we've got to create integrity products with integrity, products that won't break when they get in the field, products that won't have warranty or reliability issues, durability issues. So, and still maintaining those short design cycles. So how do we get there? Great question. This is a really trusted group that I follow. The Aberdeen Group is a third-party organization, and it's their job to really testify about what best-in-class organizations are doing in the product development community and how they're racing to get to quicker development cycles and shorter production schedules and really reach their time-to-market goals and manufacture quality products. Well, they're telling you here, right here in this article, the title says it itself, Enhance Engineering, Reduce Time and Optimize Products with Simulation Best Practices. Well, if you read the article in full, and it is available on my LinkedIn page, Danae Busby, you can connect with me on LinkedIn at Danae Busby, I list this article on my LinkedIn page for a reason, to give my community of product development an understanding of how to reach these goals quicker and understand what best-in-class organizations are doing to achieve those goals. Well, they're adopting virtual prototyping technology and integrating it with their CAD in order to see that optimized or reduced production schedule in a quicker fashion. So, in thinking about my experience as a design engineer, I question, okay, where do most design engineers start? Well, most of us start with, after we make a concept, after we answer the question of how we address, new technology, advancement in technology, innovation. Where do we start? We start at linear static. We ask ourselves, is it going to break? We choose some material, and we understand that there's some generalized force versus some, acceptable displacement that we're willing to accept before the product is no longer built with integrity. And we evaluate that with linear static. We say, okay, this material really isn't going past the point of yield. I'm satisfied. But what is stress really telling us? Yes, it's telling us, will it break? What loads can be applied? It's giving us safety factors and where the yield point of the material is. But is the model over-designed? It's not really telling us that because we don't know the most optimized approach to concept if we're only considering will it break. We're not considering, hey, if I reduce my materials, is it still integral? If I decide to take a different approach, is repetitive loading, is it still maintaining its safety factors? Is heat transfer a component of my design, and am I not considering that? All of that plays into how often is just linear statics the real world scenario. When you put a product out into the market, understanding just will it break and can loads be applied is not the necessary what I call the engineering truth, right? So predicting real-world failures is really a total approach to design. And I like to call these the 5 failure modes. Linear static, vibration, understanding will shaking or rattling affect my design, considering heat transfer, how will temperature affect my design overall, heating, cooling, how will cyclic loading affect my design with fatigue. And then buckling is a way to evaluate similar components to linear static, but it's done on thin-walled structures. And then what I like to call the bonus round, design optimization. Using goals from these 5 failure modes to understand where can I reduce material, how can I make the design lighter but still maintain strength, how can I make the design more optimized to considering heat transfer or vibration effects. So all of that is how we predict real-world failures. Now, I'm going to spend some time talking about these failure modes so we can really understand how they drive design innovation. When we talk about heat transfer, now, what comes to mind when I consider heat transfer, industry trends related to thermal management really puts pressures on engineers and how we consider how thermal management will affect our design and creating quality products. Supply and demand in relationship to thermal management is putting pressure on us to create lighter equipment. But how do we do that and still increase capacity, let's just say in high-tech electronics? The community of users out there who are listening to this webinar, you guys can identify what I'm saying. Every day somebody's coming to your office and saying, hey, I need lighter equipment, thinner equipment with more capacity. So that means the circuit board has to be able to do more. It has to be able to go farther than the last design. With technology in relationship to phones, I mean, let's be real, Apple, Samsung, Google getting in the phone market, they're all dealing with this demand every single day. How do I innovate the telephone from the last generation but still maintain, a sound component of thermal management? My phone gets hot, if I talk on it for an hour, I can feel the heat in my hand or my face. And how do I manage that as a design engineer and really make it an acceptable component in the consumer market? I don't know. Thermal management is how we get there. Economic pressures in the oil field. I do my due diligence in keeping up with a lot of oil and gas blogs and what the NASDAQ and what Forbes magazine is saying, because the oil float rush is a really critical component in our domestic economy right now. Domestic drilling is single-handedly supporting the American economy. And so if I'm in the oil and gas sector and I'm building oil equipment, well equipment, pumps, valves, I'm really critical, a critical component of my design process is understanding thermal management. When I'm putting something 60 feet, 50 feet into the ground and crude oil is hot at that level, I need to understand how that affects the integrity of my design. Technology evolution and advancement is really putting pressures and making thermal management a more critical component in the way we design sound and quality products and how we approach it. This article here is a testament of what I've been saying. Evolution and modern approaches for thermal analysis of electrical machines. This is an article that basically talks about thermal management and how it's integrated itself into electrical designs with machines, with other advancing technology. And this is also available on my LinkedIn page. I encourage you to review it. If you're designing a product where heat transfer and how that affects your design and the integrity of your product is a concern, it's something you should really think about. And if you're not adopting it and integrating it into your design from the beginning, how are you really predicting if that's going to be a point of failure once you get to that manufacturing stage? So we all know what heat transfer is, right? It's radiation, it's convection, conduction. It's considering how heating up or cooling down will affect our design. And why do you consider heat transfer? Well, we talked about it as being relevant in some of the industries, like high-tech electronics, consumer products, oil and gas. We want to maintain safe operating temperatures. If somebody's using our product in the field, we don't want that to be a part of why the part fails, one, why consumers who are using it don't consider the product safe. We want to identify thermal design problems early in the design process, so integrating thermal management concerns from the basis of content is really how we can predict those failures downstream. We want to avoid those costly mistakes because, if something heating up or overheating or there's not enough cooling going on in our design can be a point of failure. It can really be costly on the back end. And if it's not something we're considering in going into the prototyping phase, it can be a costly measure in that regard as well. Well, considering thermal management as an integrated part of our design can reduce that prototyping and that ugly design, redefine, prototype phase that we often get caught up in and really causes us to see more time put in our production schedule. And, let's be honest, for those of you who are doing destructive testing out there and going through the measures of using outsourced components for people to evaluate thermal management, it can be costly. In the high-tech electronics industry, as we mentioned, our friends like Google or Panavision or Pace America, who's designing the DirecTV boxes, we've got to be able to optimize cooling for critical parts of our design, or we can't push the envelope of innovation. We're not going to be able to increase touchscreen capacity if we don't consider those thermal effects up front. If we don't properly position vents and fans, and if we don't consider what that's doing in terms of thermal management, we're not going to get there. Consumer products, same thing. The temperatures of whatever we're designing, whether it be a motor or an engine, it can't be a danger to the consumer. And then not just to the consumer, are we considering what environmental effects is doing to our design? That's another critical component of how we consider thermal management playing an integral part to our design integrity, to creating better quality products. Medical device, again, overheating of different sensors and surfaces as it relates to the consumer, isolating temperatures during, the normal conditions, how that will affect our design. So all of that plays into creating quality products. This is a testament of how manufacturing deals with thermal management. Our temperatures from our cutting and our mills, and how that affects our spindles or our bearings. All of that it plays into a part of field failures, warranty issues and concerns. So here at GoEngineer, it's our mantra and methodology for our customer base to help you guys to understand how to adopt advanced technology simply And it doesn't mean that you have to be an analyst, or we're talking even from the designer's perspective. If I'm a designer and I just want to understand how to enhance my development process and how to be more productive, because productivity is a direct component of, if I can approach that design engineering bullseye from the start, I'm going to be more productive. So where can you find tools for thermal management in relationship to the solutions that GoEngineer provides? We have tools beyond CAD. Simulation Professional is where you can explore studies of conduction, convection, and radiation, time-dependent or for a transient or steady state. And going beyond thermal management, where you want to consider force convection and things like moving fluid flow, we have tools and flow simulation, CFD. That's in a more advanced approach, but we do have scalable tools that can help, anyone from the CAD user, the designer, on up to the analyst. So the next failure mode that I want to talk about is fatigue. Now, fatigue has become a real critical component in the product development community in the recent years, because cyclic loading or repetitive loading and understanding how that affects the integrity of our product is an approach that's been tried and true, but I think it's only in the recent years come to the light of a tool to explore, like I was saying from the beginning, from context, how repetitive loading, cyclic loading will affect our design. This is a really extreme view of how fatigue, not considering fatigue, can be catastrophic if not considered up front. Now, fatigue, in my mind, centralizes on a couple of ideas: maintainability, reliability, and the life cycle or economics of my product. So I'm an engineer, and I'm sitting at my desk, and I'm designing a product, and there are some thoughts that arise in my head. Will this design survive? How do I design? Do I have a reliable design? Is it, once it gets out into the community, will it survive? Is it reliable? And furthermore, what are maintenance or repair costs going to be? Now, all of that plays into a product cost impact that merges into the cycle of warranty and product life. And that's how fatigue can help me enhance my conceptual model from an integrated perspective, considering the failure of material due to rapid cyclic loading and the vibration. So I'm going to pull up a quick review for you guys of awesome YouTube video that I found that just gives us an identification of what destructive testing or field testing looks like when we're considered fatigue. Now, I'm showing this video to you because this is a physical representation of how we consider fatigue, but at GoEngineer, we help you understand how you can bring that into a virtual space. So now this is an overview or a picture view of different materials at failure when you consider how fatigue or cyclic loading can affect the design. Now, you might be asking today, why should I even care? Or why would I consider fatigue as a part of my design process? Well, not only product life and warranty recalls, those can be, you may not think about it on a catastrophic level, but my friends at Toyota can tell you it can be catastrophic when it comes to dollars and cents. Because when you talk about hitting that target of conceptual modeling, you're talking about optimizing in respect to weight and fabrication costs. So when you talk to a Toyota or a BMW or any automotive folks that have really experienced what product recalls cost them in the long run, in fact, failure mode like fatigue can really save you hundreds, thousands, hundreds of thousands, and maybe even millions of dollars. So using fatigue to predict upfront catastrophic failures is really what I'm getting at here. It's a key concern related to the reliability or the durability. Will your product survive? And really avoiding those costly recalls. It's something that if I were you and still doing design engineering, I would really be considering bringing on as a component of how I consider concept designing products from the initial stages of concept. So where can you find solutions for fatigue, and how can GoEngineer help you? Well, the simulation professional product encompasses the fatigue failure mode. It is the effects and study of cyclic loading, addressing the concerns of how long will it last, and what design changes will enhance my product life. The next failure mode I want to discuss is frequency and vibration. Again, frequency and vibration is probably one of the most critical failure modes that I can probably think of as a design engineer. If my product is either going on something or my product is has a motor or something where I'm considering shaking or rattling, this is a real good view of destructive testing capability. And as you can see here, this video is going to reveal to us how quickly a product can be destroyed when you're not considering how vibration and frequency will affect your design. Yeah, at the end of the day, maybe we need to go back to the beginning of concept here to readdress this design. It can be comical, but it can also be costly. So why should we care about what vibration or frequency is doing? When we talk about considering vibration or frequency, I started frequency because frequency helps us understand modal shapes. What is the shaking or the sound doing in terms of the sine curve? And how does that tell us where to enhance or improve our design, right? Because those effects can be the cause of permanent component failure. And also, it can really waste energy, right? And when we talk about how we consider frequency and the vibration, we can consider it from two different perspectives. Force vibration, when a force or a motion is applied to our mechanical systems, you know, shaking of a washing machine or truck engine or springs, that kind of thing. Or it's free vibration, when the mechanical system is set up with an initial input and allowed to vibrate freely. You know, I've got pictures here of the little child on the seesaw. So those are both aspects of how we consider frequency and vibration and how that affects our design. So when you talk about frequency and vibration in relationship to how we consider, like I was saying, modal shapes, you can do it on a time dependent. GoEngineer and SolidWorks has provided two approaches to free vibration and forced vibration. And you can find it in the Simulation Professional and the Simulation Premium package. With the free vibration, you're going to understand modal shapes and time history you're not going to go into consideration of deflection. That's the force vibration or advanced dynamics component that we have in our SolidWorks Simulation Premium package. Now you might be saying, Danae, look, this is all good. You've been talking for a while about these different failure modes and how they will affect my design. It sounds all good and well, but I'm not there yet. I'm still I'm outsourcing. I'm using consultants to test. I'm doing some sort of destructive testing or in-house, testing, and that's all fine and well. This webinar is to give you guys an encouragement to bring virtual capabilities in-house, and it can be done from the level of just merely a designer. I'm not saying that everyone on the call has to be an analyst. And so what SolidWorks has done is say, okay, let me take a backwards approach to understanding where as a product development community, where we start. And we may just be CAD users. We may just be designing a product. We're not going all the way up to advanced technology, and we're not, we don't want to force our engineering or design team to become analysts. There are a separate community of people who do that. Well, SolidWorks polled their community of user base and said, where do we start? Obviously, everybody starts at linear static. Will it break? How strong is it? How much load can we consider? But in telling the story and the truth of, like I said, catastrophic real-world events, the next thought or mindset might be, okay, if I'm considering a load, why not consider a repetitive load, or how fatigue will affect my design? And then I'd also like a tool to consider, if I'm doing all of these studies, how can I trim these studies to help me understand where to go with my redesign or refining stage? So Simulation Standard is a new product offering that we're offering in the West, in California, and we're testing the idea. If we begin with linear static, fatigue, motion for gears, springs, actuators, dampers, understanding contact forces in between gears and elements like that, and giving you a trend tracker to push innovation to the limit without risking failure, is that somewhere we can start in our community? Giving you a tool as a first pass of product integrity, addressing those upfront concerns, while coupling design with testing to enable you to reduce those production schedules, while enhancing your design process and giving you a tool to enhance productivity, to push the line of innovation, while giving you it at a low buy-in cost and a high return on investment. Well, Danae, where's my return on investment? My return on investment is that I'm able to tell more of the truth about how my product will react in real life, and not forcing my design team to become, severe analysts where we're doing, advanced consideration and equations and, pushing the levels of harmonic response or shock response. We're just giving you a low price point with return on investment that gives you a very low learning curve to initiate that coupling, going back to the Aberdeen group, creating an environment where I'm integrating design and testing at the same time. So just a review of how you can get these failure modes in other ways, and how we can help you if you're not necessarily starting at without having anything, or you may be starting at SolidWorks Professional or Premium. There are ways to upgrade and include these failure modes. If you have SolidWorks Premium, you can upgrade to Simulation Professional. Now that's linear static, that's motion, and that's kinematic motion and dynamic, and time event-based motion. Excuse me. That's thermal, that's vibration, that's buckling. To eliminate warranty concerns and increase the life cycle of your product, you get fatigued. To reduce material costs and weight. That's that bonus thing I was talking about in the middle of that second slide, optimization. If you have simulation professional and you say, Janae, I have an analyst group, or we want to go back past the basic failure mode and consider catastrophic failure events. You know, I want to push the envelope to nonlinear. I'm designing with rubber or plastics, and considering linear statics isn't the way I should approach my design because I'm past the point of yield already with the product or material that I've chosen to produce my product. So you may want to consider loading from a nonlinear perspective, or you may want to go into what we consider advanced dynamics, harmonic and shock response, random vibration, and that gives you eliminating those design barriers due to failure behind nonlinear, and adds a time response as well. So, as a conclusion, as I wrap up here, you may say, "Hey, I'm interested. So, how do I get involved?" You can contact your local account manager. You can also contact me. My name is Janae Busby. That's P as in David, E as in Edna, N as in Nancy, E as in Edna, E as in Edna. Last name Busby, B-U-S-B-Y. You can connect with me on LinkedIn. I always send that information and relevant data that I find on blogs or websites to the product development community and to the GoEngineer family. You can log on to www.goengineer.com and click Request for Contact. You can also contact your local account manager and schedule what I like to call a doctor's appointment. You work with the experts, and we basically give you a diagnosis on our approach to how to improve your product quality and how you can adopt this technology, whether it be the simplistic approach from the simulation standard perspective, or you want to advance the full 5 failure mode, into your conceptual modeling process, or you want to go to an advanced technology. We can help you understand what that looks like, and even if you want to grow it in stages, we can make a scalable implementation plan for you. We also offer what I like to call lunch and learn, food and education. It's a great combination, and as an engineer, I can identify with it. I think better, I design better when there's food in my stomach. So lunch while you learn. We can bring a presentation of these concepts on site, introduce it to your entire design team. You might be an engineering manager or a VP of product development, and you're interested in how this can play into your business model and your overall concerns as it relates to time to market and reducing those production schedules. You can. This is a view of our new and improved GoEngineer website. The event of our calendar, the event and our training, both scheduled training and our free seminars that we give are also on our website, www.goengineer.com. You can also personally email me. I'm the Simulation Product Manager here at GoEngineer. My email is dbusby, that's D as in David, B as in boy, U as in unicorn, S as in Sam, B as in boy, Y as in yellow, at GoEngineer.com. And as I wrap up here, I want to say thank you for attending our first webinar. This is a series of webinars that we're doing this year in relationship to simulation, bringing you more of an industry perspective and an under-the-hood view of the application of tools that we have in simulation and the failure modes that we can explore, and how you as our respected customer and product development community can adopt these tools simply, without headache, and with a sound implementation plan. Next week we're doing our first webinar on plastic. I'm really excited about this because this gives us an opportunity to get introduced to some of our mold makers out there. Those of you who use plastic and rubber materials as a way to design all of your product line. And this is an attractive webinar that I'm sure you get a lot out of. It's going to be interactive. We're going to show you the tool. We're going to go underneath the hood and show you how to create studies, how to understand if my coordinates have you are designed properly, where the sink marks are, how do I evaluate weld lines, and how do I consider warpage. All of that will be on next week's webinar, next Wednesday, February 12th from 12 to 1. And it's going to be given by one of my awesome colleagues, Corey Bauer, who is an expert in the plastic design space. And if you have any questions or concerns, again, please, please, please log onto our website, or you can connect with Danae Busby on LinkedIn. Email me personally at dbusby@GoEngineer.com. Again, I thank you for your time, and as always, design with innovation and push the limits. Thank you so much.